All right, welcome back. This is lecture 10 of Computer Science E76. Tonight we conclude a lot of our look at iOS in particular, because next week we'll have actually a guest lecture. More on that in just a moment. And in the final lecture, Dan will return. We'll do a little bit of Android and iOS and wrap up the course. But the true climax is meant to be this app party. So on Friday, May 4th, this is in the syllabus, as well as additional details, will be the course's app party. So those of you who are local and even distant, if not too distant, are more than encouraged to come join us on campus, not only for an exhibition of each other's projects, particularly your student choice projects, which no one will have yet seen, but also for some cake and some other such sundries to enjoy. And really the motivation here is to bring together a class that's right now about 100 people to delight in each other's projects, to meet each other, perhaps for the first or the last time, and really get a sense of what others have been working on throughout the semester. So if you're able to come, please do, and family, friends, colleagues, and kids and such are quite welcome. So next week, or 2 weeks rather, is our final lecture in which Dan will return, and we'll cover a number of things like submitting apps to the app stores, respectively for Android and iOS, as well as tying together a number of similar topics in both platforms. Next week we'll be joined, in my absence, by Edwin Guarin, who's an evangelist at Microsoft, to talk a little bit about the world of Windows mobile development, as well as the world of web-based development through tools like PhoneGap, which allow you to wrap web applications with native code so that they too can run on Windows devices, on Android devices, iOS devices, and the like. So he will be here next week with us. All right, and where did we leave off last time? Storage. All right. So we did start talking last week about a number of mechanisms whereby in iOS you can store data persistently. A couple of these probably are or should be sounding familiar if you've dived into Evil Hangman. For instance, property lists are quite germane. What is a property list in iOS? And in macOS programming as well. What's that? So it's an array of strings, potentially. It can also be what else besides an array? Sorry? Primitive data types can be inside of it. A dictionary is another common container. Yep. Key value pairs. Yeah, so more generally, it's key value pairs of some sort. And a property list underneath the hood is actually just what? It's just XML. It's just a text file, but even though Xcode presents a graphical view of it, at the end of the day, it's just an XML file. And the graphical view it puts forth is really a list of key value pairs. So one misleading detail in that view is that it says, literally, I think in the headers, key and value, which suggests that any property list is in fact a dictionary, which will have you run into trouble if you try loading into an NS dictionary the contents of words.plist or small.plist from the Evil Hangman project. Realize that you need to load it into an NS array. And if you look at the actual plist file with a text editor, you will see that it's indeed not a dictionary, but in fact an array. So another storage mechanism with which you'll soon be or are already familiar is NS defaults. What do NS defaults let you do? Yeah, so store preferences. So small pieces of information, like in the game of Evil Hangman, what's the default word length? What is the number of guesses you want to allow the user? And other such settings, so that you, when you first fire up the application, one, there's a standard mechanism whereby you can seed those defaults with themselves default values, but then also the user can override those. In the case of Evil Hangman, on the flip side controller, changing some settings, and then you can save those settings persistently without needing something like SQLite, without needing to come up with your own file format. It's a very nice way of storing some foundation class primitives through an abstract API known as NS defaults, which itself is a model of sorts. As an aside, there is a way also in iOS to store settings in a truer sense. If you go on the home screen of iOS, there's a settings icon with gears and whatnot, and that gives you additional access to applications preferences. That's not the means by, you don't set those settings by way of NS defaults, or you don't necessarily, NS defaults is distinct. So that does beg the design question, why put some application settings right in the app itself, for instance on the flip side controller, whereas some applications instead relegate their settings to the home page, the settings icon, and then the name of the application itself? Particularly if you have an iOS device. What would motivate one decision or the other?
Well, if those settings are pretty common,
Mm-hmm.
and like getting an alert or something, then you could set it on the settings, right?
Okay, so for things like that are fairly generic in nature, like whether or not you want notifications, whether you want the phone to beep or vibrate, arguably settings that you probably aren't going to change all that often. You might change it once and then forget about it. By contrast, the game of Evil Hangman, it's reasonable to assume that the user might care to give him or herself more guesses or fewer guesses, change the word length. And what would be motivation then for just using NS defaults and this flip side view for settings as opposed to the settings icon itself? Yeah.
You don't have to exit the game, dig through a menu, make your code, and then go back to the game.
Exactly. It's just a pain in the ass, right? To go actually back to the home screen, click settings, go through some menu of options just to change a game setting, then re-foreground the application. I mean, why make the user jump through all of those hoops? So for settings that might want to be changed on a more frequent basis, maybe sound volume on or off, whether or not to play music at all, again, settings in something like Evil Hangman makes sense to just integrate them right into the app itself. But something like, do you want notifications every time the game is updated? Maybe that's something that you set once and forget about, but you don't want to hide it altogether from the user. So a design decision in the spec for project, the iOS Staff's Choice project only prescribes the use of NS defaults. No need for settings. So what is, or was, if you recall, SQLite? Lightweight. The database? Okay, very good inference. What does that really mean? What is it more technically? It's a database file. Yeah, and it's just a file, right? So it's a SQL-based database mechanism, but that's fairly lightweight in that it stores everything in one big binary file. So you don't have the overhead of an actual database server, something like MySQL or Oracle or MS Access or the like. Instead, you still have the expressive capabilities of SQL, selects and inserts and deletes and updates and all of that crud, so to speak. But you don't have the weight or the complexity of actually running a separate server. And certainly in the case of a mobile device, you don't need to talk to anything on the internet. You can still store data on the device itself while being able to do joins and being able to model your data in a traditional relational way. So SQLite is one of the capabilities that you get on the iPhone. For better or for worse, let me go ahead and open up an example here called SQLite, which simply implements a very simple table view controller. Let me show what it looks like before we glance at the code, just to remind you that underneath the hood of a lot of iOS programming is actual C code, which is, at least syntactically, perhaps for the worse sometimes. So here's a little example, and it happens to have the 5 words that we gave you in small.plist, which is on the projects page. It's just a sample file, much smaller than words.plist. And you can see the horizontal lines here. This is a UI table view with a UI table view controller. And it's a very common iOS paradigm to have lists of things that might have buttons and things you can click on. But in this case, it's really just a simple list. I just wanted an easy way to spit out a small array. So as always, how do we start our tour of a new project we're looking at for the first time? Glancing at main isn't a bad point if at least it orients you mentally as to where the story begins, but there's rarely, if ever, anything of interest there, because UI application main is then immediately called, and that should then draw our attention to which of these other files most likely. Yeah, so app delegate. If we care to really follow the story chronologically and see where the first custom code, as opposed to template code, kicks in, might start with the app delegate.h. This looks pretty vanilla here in that we don't have any mention of anything that doesn't come with a standard single view template. And here we have appdelegate.m. There's also nothing really interesting here. I seem to be allocating a view controller, initializing it with a nib. So that feels to me like we should probably look at the view controller. So let's look at the h because it's smaller. Indeed, there's really nothing there, though this is in fact necessary. And then view controller.m. Okay, so here's some interesting stuff. So let's scroll up to the top and see if we can't piece this together. So first, as a quick review, this chunk of code here, what's the piece of jargon that describes this technique here? This is a
property.
Okay, this is a property.
And you're creating getters and setters for this later on.
Okay, good. So thanks to properties and thanks to the @synthesize keyword down here, you have the ability, one, to introduce the dynamic creation of getters and setters, which is just nice and that you don't have to deal with it yourself. And you can influence the creation of those getters and setters by way of these attributes here that specify what kind of boilerplate code will be given to you. Is it atomic? Is it not atomic? Is it just a getter? Is it a getter and a setter? How are pointers handled with regard to strong? Now, why have I bothered wrapping this inside of @interface view controller and then open paren, close paren? Okay, so I didn't put it in the header file, which means the parentheses are now necessary because this interface has already been declared. So why not just move that private property to the .h file?
Something that nobody else needs to really know about.
Yeah, exactly. If this is a property that no one else needs to know about, then there's really no need to advertise it publicly. And this, too, it's hard to sort of find this compelling, I think, in a limited context where who are you talking about? This is such a small application to begin with. But the principle of it certainly applies. And with Evil Hangman, depending on how you implement your models and how you decide to implement your view controllers, might very well be more compelling to really hide details between two classes from each other. So in this case, it's just a reasonably good practice and increasingly common. This is a generic example or a specific example of a Objective-C category, which allows you in the parentheses to specify a name for this category. And much like in JavaScript, you can extend the functionality of an existing object through its prototype property. This is the same idea here. But the nameless parentheses simply is called class extension, even though functionally it's just a category. All right, so we have an NS mutable array of words. This gives me the getter and setter. And there's one other feature of properties that's on our list of 2 features that's compelling. You get the dot notation, the syntactic sugar, which just makes the code a little more readable and more succinct to write. So now let's look at the initialization method. So this is a view controller, so there's going to be a bunch of potential places to put code. There is view did load, view will appear, view did appear, view will disappear, view did disappear. There's a lot of, frankly, methods where it feels like, do I need to? Do I want to put something in there? And recall that from last time we talked about init methods as being the place to really do any kind of initialization logic that's independent of the actual view. That has nothing to do with aesthetics, but does have to do with the program's underlying logic. So I did a whole bunch of work here. And again, the context is using SQLite. So this method name, I just copied and pasted from the documentation. And it is, in fact, necessary that I implement this thing, init with nibname bundle, instead of this guy, y. Exactly, right? And my hands are kind of tied because recall that where the story began was in appdelegate.m, and this guy has the boilerplate code, or maybe I wrote this manually myself, says init with nibname bundle. So that's the init method that's in fact going to be called. So in the view controller, let me go back to the M file and see what I'm going to do. This is just very common paradigm. Anytime you implement your own init method, be sure to call the parent classes, even if it takes no arguments, even if your parent is NSObject, because you don't know what initializations Apple might need to do now or in the future. Now I'm going to go ahead and prepare for words. So I allocate an immutable array with alloc and init. Again, a very common paradigm to do this in the same line. And now I connect to the SQLite database. And here is our C code again. And this is where syntactically it gets a little interesting because we're pretty much alternating between C and Objective-C. So this just gives me a pointer to what, probably? Even though you might not have seen this purple word, SQLite 3, before, what is it probably? Database handle. OK, and how about more technically, or in terms of syntax, what does this represent? OK, so that's more conceptual, I would say. So what is SQLite 3? It's an object, but this is C now. A data type, yeah, and really a struct. So it's probably a C struct. And frankly, you wouldn't necessarily know this by looking at it. It could be an Objective-C class. The slight tell is that it's all lowercase, which just doesn't follow the Objective-C convention. But if we actually held Option and hovered over this, we could actually see the little cheat sheet that says this is indeed a C struct. So there's some data members inside of this. But DB itself, at this point, is just a 64-bit pointer to a struct of that type. Now, in the next line, we're calling NSBundle main bundle, which essentially gives you back a pointer to the object that represents the .app, so the folder that your application will occupy in the iOS device. Path for resource is going to give you the equivalent of C:\/ something, but in the context of an iOS app. The name of the file that you're asking for is small.sqlite. And in this third line, SQLite 3 open, another C call, and here too is where it's a little weird commingling C and Objective-C. I'm passing to this C function the return value of the path being passed the message UTF-8 string. So I check the documentation, and SQLite 3 open expects a UTF-8 string, but a char star version of it. And then the second argument here is meant to be not a pointer per se, but an address, but it's a pointer to a pointer in this case. Now, if you're a little rusty or uncertain as to when and why to use those, don't fret too much, because to be honest, if you're using SQLite, you can just take at face value. This is the paradigm that you have to adhere to. This is how you use this library. But at this point in the story, after these 3 lines of purple code, we have a connection of some sort to a database that just so happens to be local. And it just so happens to be a binary file, but it's still like having a MySQL_connect call if you're from the world of PHP, or a JDBC call in the world of Java that connects to some remote SQL database. So now we get to go back to a little bit of Objective-C where I create an NS string, that's this thing here. Then I apparently allocate a pointer to a SQLite 3 statement structure. Then I use this prepare method, which itself is a little complex, but we can kind of infer what is going on here. I'm passing it the database handle. So the prepare statement knows what connection it's preparing a statement for. This is just the char star version of my SQL query. And I could have done this in a couple of ways, but NS strings are just nice because I can literally just type them out, and then I can get back the UTF-8 representation. Ampersand statement is a pointer to this pointer, so I can actually mutate its value, and then nil in this case. So at this point in the story, I have prepared a SQL select, and by prepare, this is a database feature. It is a statement that I can execute fairly efficiently again and again and again. Prepared statements are particularly helpful if you're dynamically plugging in values, like an ID or some string value. Yeah? I actually don't remember. I was hoping you wouldn't ask. -1 and nil, I don't remember what those fields are. But good question. All right, actually, well, I should at least do the educational thing. Let's hold down Option, click on the method there. That's why I don't know, because the manual didn't tell me when I last forgot. All right. So this last part. This now is simply code whereby I'm going to iterate over the rows that are returned from the select statement, and I'm just going to load them into my NS array. Now, just one step back. Small.sqlite, just to be clear, is just a binary file I created in advance. I wrote, as an aside, a little PHP program to just dynamically create a SQLite database, and it's cross-platform. SQLite is a generic technology that can be used in all sorts of contexts, Objective-C, PHP, and the like. And then I just dragged and dropped it into the application, and indeed you can see it right there. Under supporting files, the white icon, small.sqlite. So assume that you've been handed that. We didn't have to create the SQLite database ourselves for this example. But now that I have my select, I'm going to go ahead and step through it, which means give me one row after another from this query. And there were 5 words, recall, bear and duck and so forth. This next line is going to call SQLite 3 column text, which is essentially asking me for the 0th column that's returned by this statement. And what did I ask for? I asked for one column called word. So this is going to give me one word as a char star. Why char star? It's a C function, so it can't return to me an NS string. So I get back a char star. And then what am I doing? I'm effectively converting that to an NS string. So this is some nice boilerplate. If you want to convert a C string to an NS string, you can do something like this. And then thankfully, we're back in Objective-C for real. Self.words is my local NS mutable array, and I'm just pushing another word onto it. So this loop's probably going to execute 5 times in the case of this file, and I'm going to push 5 words onto this NS array. And then thankfully, the rest of the program has nothing to do with C or SQLite. It's only used in the initialization to load these 5 words from disk. Yeah?
So why isn't there any Objective-C library for this?
So it's a good question. So with core data, which is an abstraction layer, you can actually use Objective-C underneath the hood, but you don't have to worry about the semantics of SQL itself. So there are layers on top of it. There might be some third-party Objective-C libraries on top of it. I don't know why Apple has not included it themselves. It's worth noting, too, it was only in iOS 5 that they finally gave the world a JSON library and a more versatile DOM library as well. So just takes time, if nothing else.
Because this is pretty common in Android, SQLite.
Indeed, no, and it's not fun code to write, to be honest. So not sure whether there's an actual history there or if it's just hasn't been high enough priority. All right, so this is actually an interesting opportunity now to look at the UI of this thing and another common scheme in iOS, which is these table view controller. So here's my nib file. And somewhat confusingly, this is not data I typed in. This is just a list of, I think, subway stops or Caltrain stops in California. But this is just the pictorial representation of something called a UI table view. So how did I do this? Well, if I expand my hierarchical view of objects, let me zoom in over here. This is what this looks like. Table view is one child. So really what I did when creating this, I'm going to go ahead and delete that with cut. That's how I started. And then I opened up the inspectors here. I scrolled down, 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 looking for this table view. And then I dragged and dropped it right there. All right, let me undo my change so my outlets don't get messed up. And now I'm at this point in the story. If I now right-click this, I had to do something else as well. This UI view, specifically this UI table view, has two outlets associated with it. Or rather, has two properties associated with it that need to be wired up. One is called data source, one is called delegate. So these serve two different purposes. Data source is a pointer to some object, some class that's going to provide this thing with data. Where are the rows going to come from? It's not going to be Bray and Burlingame and Canoga Park and so forth. The data has to come from somewhere. So the pointer for data source means who am I going to ask for the data for these rows? Meanwhile, delegate is kind of in the opposite direction. When the user interacts with me by touching the row, touching the button, dragging, who am I going to tell that that just happened? So that's a pointer in the other direction. But in this case, they're both pointing to the same file, to file's owner. And in this case, what kind of object is file's owner? If this is viewcontroller.nib, it's viewcontroller.m, or viewcontroller, the class itself. So if I now go back over here, let me scroll back over to viewcontroller. Let's see what else is in there. Well, one, notice in the H file, I breezed through this earlier because there was nothing really interesting there. But there was a little something there. It's descending from UI viewcontroller. So let's now see how I'm going to wire up the data source. So that's the init method there. And notice there's a few things here. Notice this. So this is a new method. Number of sections in table view. We've seen this one before. Should auto-rotate to interface orientation. Table view cell for row at index path. That's interesting. Table view number of rows in section. So it seems that I'm adhering to some kind of delegate here. And indeed, these are methods that I need to be implementing if I'm going to act as the delegate and data source for a UI table view, the thing I dragged and dropped into my UI view. So a couple of these methods, actually all of these methods, have to do with the presentation of data there. So it looks like there's three. Let's pluck off the easiest one first. In the story related to data source, one of the questions that the UI table view is going to ask this class is how many sections are there in the view. Now what's a section? In the default application here, this thing has one section. And by contrast, if I open up, let's go to settings. This screen here has two sections. This top one is a section. This bottom one of 4 is a section. So section has to do with this ovular structure that has one or more options in it. So that's a section in the table view sense. It's really just an aesthetic thing. So now if I go back to the application, this thing has just, okay, crashed. This thing has just one section that looks like this. So this is why I hard-coded the answer the value of 1. So how many number of sections in table view? It's just hard-coded as 1. All right, so now what else is here? Let's do this one here. Number of table view, number of rows in section. Well, this is asking me the question of how many rows are there in section. This is just an integer or an int. So presumably the number that's only going to be passed in is 0 because there's only one section in question. So now I have to return a slightly dynamic answer. I can't hard code this a priori because that actually has to relate to the number of rows that were in the SQLite database itself. But I already loaded those rows from the SQLite database into my NS mutable array. So I just ask my mutable array that question, count. Good question. If you return the number 3 instead, you should be OK in that case because it will only ask you via the next and final method that question 3 times. What do I put here? What do I put here? What do I put here? If by contrast you say that there's 10 rows, but there are really only 5, then you run the risk of indexing beyond the bounds of an array. So you'll see garbage or you won't, or you'll see nil values or blank values in that case. All right, so the last one is the more involved one. So let's see what this thing is doing. So table view, cell for row at index path. So an index path is apparently a class unto itself. I'm not just being asked for a section now. I'm not just being asked for a row. I'm being asked for an index path. What's an NS index path? It's a structure containing a row and a section together. That's all it is. So I can ask that object what row it's asking about and what section it's asking about. So let's see what goes on here. So first I have this static identifier, static string called @cell. This is arbitrary. This could be foo, and we'll see why I'm using this in a moment. Now this next method is dequeuing a reusable cell with identifier, quote unquote, cell. So somewhere in memory there's apparently a buffer that has some chunks of memory, each of which represents a table cell, a rectangular view. And I'm simply saying, give me one of these cells for this identifier. The motivation here is ultimately going to be efficiency. So more on that in just a moment. In the next line of code, I'm checking, well, if cell is nil, that means there were no available table cells in whatever buffer is accruing in memory. So I'm going to go ahead and have to explicitly allocate a cell. What kind of cell am I going to allocate? A UI table view cell. Then I'm going to initialize it with a certain style, which is this constant, UI table view cell style default. That just means give me a big boring rectangle. And then it says reuse identifier, cell identifier. So I'm informing iOS what name I want to use to refer to this type of cell, so that if I ask it in the future for another such cell and one is available, it's just going to hand me that one. So what's the motivation here? Well, it's not quite useful in this application because we only have 5 rows. But if you imagine a dictionary with like 150,000 words, for instance, if you actually did want to scroll through all of those words, that would consume a whole lot of memory. Like not just memory for the individual letters, but memory for the individual rectangles here and the gray lines in between them. So that's a lot of RAM and 150,000 of them. But if you're the optimization expert, what's the opportunity here for improvement?
You reuse the cells for your data.
Exactly. You can reuse the cells for your data. You don't need to allocate 150,000 strings and 150,000 table view cells because, frankly, only 10 or so of those are ever going to be in view at once. And maybe as you start shifting, maybe you start to see an 11th one, but certainly a finite and small number of cells actually need to be around at any given time. So indeed, for efficiency purposes, what iOS does is as you start to scroll up, for instance, as soon as bear is off the screen, that UI table view cell could be reclaimed, its memory. So the string will remain in your NS mutable array, but you don't need the additional bytes for that row in the table, so it might be reused and sort of be reborn at the bottom of the list, so to speak. So the fact that I'm using this reuse cell identifier is just ensuring that I'm only allocating as many cells as I actually need. And it's wonderful for the efficiency of it. If you have an iPhone or an iPad and you load up a huge list of data, it's actually remarkable how quickly it scrolls, even if you have a lot of contacts, because only a finite number of them are staying in memory at once. And the phone is faster than humans, so it can at least do this wraparound and give you another cell before you actually scroll up. So it really minimizes latency. So how do we answer the question finally? Well, this is just fluffy aesthetic stuff. I'm going to change the selection style to none because I decided arbitrarily if you click on these rows, I don't want them to turn blue because this application doesn't do anything. So I disabled that. And then I have to change this text to be something. So cell.textLabel. This is referring to an actual UI text label in the cell itself. That's a property of that UI table view cell class. And then I want to go ahead and get the object at index, whatever this is. Well, this, recall, is an object that contains both a row and a section. I don't care about section because there's only one of them, so I just need to know the row. And voila, I can plop that in for the value of text. So we started the story with SQLite, but we ended the story with an implementation of a nice little table view here. Questions? No? OK. So let's see what else we can use in the way of storage. So there's SQLite. There is also XML and JSON. It's not clear that you would necessarily need or want to use these storage mechanisms yourselves locally, but certainly if for your student choice project you want to read some data source off of the network, off of a network connection, expecting that data to come in the form of XML or JSON is pretty common these days, and there's nice parsing capabilities built in for those. And core data, again, is this abstraction layer that allows you to really, with another WYSIWYG editor, drag and drop some of your entity entities and your relations among those entities, and then relegate to or delegate to iOS the actual implementation details, where all of the entities you create will somehow be embodied in SQLite tables and rows, but you don't have to care about those details. It's a little bit involved. It's not expected for the staff assignment, but for the student choice project, by all means, feel welcome to dabble into core data. There's a little checkbox you can check when starting off with a template, and either of the course's recommended texts give you a bit of pointers on that, and Apple has some documentation as well, but it's a little involved. Yeah?
SQLite file at the end for that core data?
I'm sorry?
It creates SQLite database?
It can, yeah. That's one of the underlying storage mechanisms, and I think the default one. But you don't have to worry about the actual, you don't have to write any SQL code yourself in that case. All right, so memory management. Kept promising for a couple of weeks that we'd finally come to this and try to peel back this layer. So let's have this conversation, if briefly, since things have gotten easier in the past year with iOS 5 and Xcode 4.3, of how memory is actually managed in iOS. So we've been calling a method called alloc. And when you call alloc, there is still, underneath the hood, the notion of reference counting. And the way memory management is done in iOS is that anytime you instantiate an object, there is some counter stored inside of that object that keeps track of essentially how many people care about this object's existence. By default, that value is 1. So when you call alloc, the reference count, so to speak, is a value of 1. Now, typically, if that object then goes out of scope, because the method returns, if no one else is keeping a pointer to that object and it's gone out of scope, it's a candidate for reclamation by the operating system to take back the memory formerly occupied by that string or that student object, whatever it actually is. But there's certainly a lot of examples, especially in a very event-driven architecture like iOS, where lots of stuff is happening, users are touching and pressing and calls are coming in, where you have fairly short methods overall, a few tens of lines maybe, and they tend to return fairly quickly. So things are very often going in and out of scope. But if you want those objects to persist across method calls, as you certainly do even in our simple example where I had an NS-mutable array and I wanted to make sure it was accessible everywhere, you need to make sure that your pointers remain valid in all contexts or scopes that you want to use that object in. So as of last June and prior, human developers would have to do all of this reference counting themselves. Anytime you call alloc or copy, or a couple of other methods, you would get an object back that has a reference count of 1. But anytime you wanted to make sure that that pointer stayed around, for instance, after a method returned that you wrote, you would have to manually call a method called retain on it. And retain is just an increment operator. It would take the reference count from 1 to 2, for instance, so that when that object then does go out of scope in the method that allocated it, and its reference count is decremented, it goes from 2 to 1, but not to 0. And the way memory management works in iOS with reference counting is that anytime an object's reference count does go to 0, the memory is reclaimed. And it's slightly distinct from garbage collection, which does not typically kick in the moment an object is no longer in use. Rather, garbage collection happens somewhat non-deterministically, where once in a while, the runtime, like the Java VM, will go through its linked list of objects and say, are you being used? Are you being used? And if not, all of that memory is reclaimed. And one of the downsides typically with that approach is that garbage collection can happen at really inopportune times. For instance, I'm in the middle of sending a text message and then it just hangs for half a second, for a second, because the damn thing is garbage collecting multiple bytes or kilobytes or megabytes of memory at an inopportune time. So doing this housekeeping more frequently with much smaller amounts tends to eliminate the non-deterministic pain points of UI for users. All right, so the problem, though, is that humans are not very good at memory management, right? If you've learned C in the past, you've certainly dereferenced null on occasion or bogus pointers, you've seg-faulted, right? We humans are not very good at perfection. And so one of the upsides of Objective-C, the latest version of Objective-C in iOS 5, is that we don't have to think as much about the +1 and the -1. And indeed, there was another keyword called auto-release, which we still see in one form, in main, in fact, and you can use it elsewhere, whereby there was this problem as follows. And let me give an example of before and after to make this a little more concrete. Let me just pull up a little text editor here. So here's a little text editor. So back in the day, if I had, let's say, a void foo method, and I actually wanted to allocate an object, I might do, let's say, ns string, star guess s, get ns string, alloc, and then I'll call init. Whoops. All right, so now I have a string, and then I might do something with it. And if I actually want to keep this thing around, s retain. And actually, let me do this. Assume an ivar called, let's do this. Instead of declaring a local pointer, suppose that s is actually an ivar inside of the object. And I allocate now an ns string with alloc. I initialize it, and then I store inside of this ivar, which is an ns string pointer, I store the return value of that method. So the problem is that if I want to keep this pointer around, I better call s retain. If I want to, actually, let me think here for a moment. Bad example. Let me fix this. I'm going to tell the story in slightly different order. I was combining two stories, which is just going to make this more complicated. So let's do ns string star s, do something. Here is what I used to have to do. So when I allocate an object with alloc and then initialize it, and then I do something with that object, it is up to me to actually release it before this method returns, because that is the last moment in time that I have access to this particular pointer s to decrement its reference count from 1 to 0, thereby informing iOS that I don't need this anymore. If I had left off that third line of code, s release, what would the implication be, do you think, for memory? Exactly. The object would be lingering around in memory, so it would be a memory leak. And indeed, iOS Xcode comes with a tool, among others, for detecting memory leaks, which formerly was even more useful than it might be now, because it could detect things like that and instruct you to actually call release. Now, there are other contexts whereby if I allocate an object, I want to be able to do something like this. So now let's tell another story. So this is now a bar method. And suppose that I have this, ns string star s gets ns string, string with format. And let me shrink the font size here so it all fits. Hello. So this thing here is generally called what? Yeah, so it's a convenience method. It is a method that allocates an object, but without the annoying hoops of saying alloc and then calling init. So the alternative would be alloc and then init with formats. And it's just more tedious to write all of that. But there is now a downside, at least previously in iOS 4, whereby if I now have this pointer s, and this object has a reference count of 1, I kind of need to decrement it somehow. But it's not up to me to actually do the decrementation, because the heuristic historically was that only the method that calls alloc, or as an aside, retain or copy, which are related in spirit to memory management, but only the method that calls alloc should be the one to call release. Unfortunately, something like string with format, if it calls alloc, it better not call release, because I need that pointer to be legitimate. So you needed a way of saying, you release this eventually. And indeed, that's what the auto-release keyword would do, whereby if I were implementing the string with format method, somewhere in that method would be a call to string s auto-release. And what this did, and I mentioned this not so much for historical interest, but because there's so much documentation still out there, so many tutorials, so many books that still talk about this, and in older code you'll still see these calls if you're not using Arc. What auto-release would do is it would add that pointer that was just allocated to something called an auto-release pool. And an auto-release pool is just a chunk of memory from the so-called heap in a memory's process space, and the auto-release pool is drained eventually. And when that pool of memory is drained eventually, anything in it is reclaimed at that point in the story. So if you think back to main now, we do have at least one auto-release pool in this program, right? Where do we keep seeing it? It's in main. So at this point in the story, or based on this version of the story, there's one auto-release pool. So at least when this application finally quits, right after this line returns, the UI application main returns, and we hit this curly brace here in the return statement, at that point you'll be done with the auto-release pool, and all of your memory will be reclaimed. But there was also a way, and there still is a way, to define your own auto-release pools. So a possible approach these days is if you have inside of one of your own methods something like for int I gets 0, I is less than big number I++. If you have a very tight loop that is in fact allocating memory unto itself, you can have an auto-release pool even inside of this thing here, so that you can effectively tell the loop to free that memory on every iteration, so that you don't build up a huge amount of memory just because this loop is really big and you're allocating. So auto-release still exists, even though it's much less common these days to have to worry about. So in short, the takeaways are, most of this is not as important to use in iOS 5, especially if you are enabling automatic reference counting, which the project specs do require that you use. And it has made life simpler, but there's still innumerable references to these other keywords, retain and release and auto-release. In fact, even in a lot of the header files for the foundation classes, there's still mention of retain instead of strong and weak for those same reasons. So as an aside with regard to synthesis now, to come full circle to the previous discussion of properties, nowadays with properties, you declare the attribute as strong or weak. Weak just means it's not my pointer, it's okay if it becomes nil. Strong means I do care that this thing remains resident in memory. So what strong is effectively analogous to is retain. When you specify that a property is strong, that means that the setter that is synthesized for it will call effectively the retain method and +1 that object for you so that it sticks around, whereas a weakly synthesized setter will not do that +1. So in short, it just boils it down to +1s and -1s. And when things go back to 0, that means the memory can be reclaimed. Yeah?
So when you said, when we mark it as weak, you said the R counts it down to 0 and it's a candidate for reclamation.
Mm-hmm.
But when does it actually do the reclamation? Is it when the application quits or during the program?
No, when is the memory reclaimed? In that case, typically at the end of the method call. When you're still in that run loop, the operating system could say, okay, you don't need that memory anymore because the reference count went to 0, I'm taking it back.
So it will collect it.
Correct, yeah. Yes, no, and that's what ARC is, ARC, automatic reference counting. It automates a lot of this process and puts the intelligence in the compiler and the runtime and takes it away from the human, which is generally a good thing.
Is there a particular reason you would leave ARC off?
Oh, good question. A reason to leave ARC off if you just philosophically are against it? There's probably a minor performance penalty because there is some more intelligence going on, and the programmer might know better when to retain and release things. But moving forward, I would probably say no downsides really besides that. Well, that, and if you want to support older hardware like the iPhone 1 or 2 that's still running a much older version, implications there. But Apple has a habit of getting people to upgrade pretty quickly. Yeah?
What kind of properties, what's the example of a property where I would use weak instead of strong?
Good question. When should you use weak properties? Thus far, I would say IB outlets is the one we've seen. So IB outlets that are meant to be wired up to nib files. And those nib files, recall, typically are the result of our dragging and dropping like a text view or a label or a button. So in that sense, the nib owns that object. So in your code, you don't own it because you're literally not calling alloc yourself. So your property for that IB outlet can be weak. So for IB outlets, a reasonable rule of thumb is make those weak. But for almost any other property to declare, it's probably best to make it strong. Worst case, you're just going to be using too much memory because you're keeping things around unnecessarily, but that's a reasonable rule of thumb. Yeah, Gloria?
Would you make delegates weak too?
Would you make delegates weak? That's a good question. That's a good question. So my instincts say to make them strong because the whole idea of a delegate is that there actually be an object there to send things to you. So I would propose yes, but let me noodle on that one a little more. I don't have as ready a rule of thumb there. It's a good question.
Like if the delegates give you a strong pointer to you, and you keep a strong pointer back to the delegate, doesn't that cause
So that in of itself isn't bad. I mean, in the example of the utility application where you have the flip side and main controller, both the first of those, main view controller, is going to be resident in memory for the lifetime of the program because it's making the flip side a modal controller. If you had a higher level object that were multiplexing among multiple view controllers, the view controllers themselves could be deallocated. But I would say strong feels right here if it's relying on certain behavior. But if I decide otherwise, I'll post to the help board. Good questions. Another question here?
He already asked.
OK, perfect. All right. So in short, memory management this year, much easier than last year is really the takeaway here. All right, so localization. So this is actually sort of a small, fun, bite-sized topic, and it's the sort of thing that too many people think about too late, where you've actually hard-coded a whole bunch of English strings into your application, and then you realize, damn, just to make this thing compatible in Spanish or French or Chinese, I now have to actually touch my code as opposed to just a file. So localization in iOS is actually quite easy, and you can do it in a couple of ways. Let me go ahead and open up this example here, Hola 1. And run this thing just so we can see what it looks like. And in the simulator here, we will see just a simple little greeting called Hello World. However, if I did this right, and I go into the simulator, and I reach the home menu, and I go over to my settings, and click on General, click on International, click on Language, and change this to Espanol. Done. It's changing language, ... adjusting language. OK, and now I go back to the application, Hola 1. Whew, it worked. So it knew that the context has changed, and now it's showing me this. So there's a couple of ways to do localization in this way. First, it's worth noting, same exact program, it's only the views that are different. So the simplest way to do localization, which is not very scalable, is you actually have a nib file for English people, you have a nib file for Spanish-speaking people, and other nibs for other languages. For a program as simple as this, that's actually trivial to do. I can go ahead now, and let me close this project, and I'll just quickly do something from scratch. Let me go ahead and start with a single view application. I'll go ahead and click Next. I'll call it Hola 1 again. I'll store it on my desktop. And then I'm going to go ahead and click Create. And I'm going to go into my default viewcontroller.nib. I'm going to very quickly drag a label over here to the middle. And I'm going to say, this time, hello, world. I'll go ahead and drag and recenter it. Let me go ahead and move it here so it's perfectly centered always. Center it up here. OK, and save. So done with that. And now if I go over to my inspectors here and scroll down under this guy, so third from the left, the identity inspector. Nope, not that one. There we go. Under the file inspector, down here on the left, notice we have localization. And by default, it only says English. But if I simply click on this plus, scroll down through the list, and I can keep going if I want under Other and see a longer list, I'm going to choose Spanish, ES, and I click Enter. Now I have two languages over here, but more interesting, notice what quickly happened over on the left. Now this becomes a drop-down. So there's actually two versions of this nib. By default, I just got a basic copy of English. So highlighting in English does not look any different. If I now choose Spanish, it still looks the same because it's copy and paste. But I can instead say now Hola Mundo. And now I have two different nibs. And now iOS handles the localization for me. I just have to compile this, run it, put it on a phone. And then depending on the user's language setting, he or she will see the appropriate nib file. So this is great, nice and easy. But we've certainly seen applications where your strings are not coming from manually dragging and dropping them, but actually coming from code. So we need a more generic way of actually doing this. And thankfully, we can generalize this. So in Hola 2 here, which is also available on the website if you'd like to play along after, there's a couple of differences. So what jumps out at you on the left-hand side? There's some new files now. Yeah, that was all correct. All right, so localizable.strings, which is just a special text file up top there. It looks hierarchical because it too has an English and a Spanish version. And then down here, there's info plist.strings. So just to see what's inside of these, let's look at the latter first. If I go up in this English file, notice that there's this very special constant name here. CF bundle display name equals quote unquote hello. This is going to be the name of my application when it appears on the iPhone's desktop. So the name of the program itself. But by contrast, for Spanish-speaking people, I'd like my app to actually be called hola instead of hello. So I have this file here, which just changes the name of the application. So this is a convention. It's got to be info plist.strings. It's got to be quote unquote CF bundle display name. And that refers to the application's bundle name, hello.app or hola.app on the desktop. So interesting, but pretty trivial. More interesting is to actually put strings in the application itself. So this time, notice my nib is just generic label. I didn't even bother putting any English or Spanish words there. And notice, though, I do have an outlet to something called label. So this apparently is an IB outlet in my code because this program is going to have my code in Objective-C talking to the nib file, talking to that UI label. So if I scroll over here, my viewController.h has a declaration here for the UI view controller, and then in here, a little private property for the IB outlet. So here is again an example of a weak property because it's the nib that's going to allocate that object. I just want a pointer to it that I can access when it's actually of interest to me. So auto rotate to interface orientation, not all that interesting, but view.didLoad has this code here. Pretty simple. I call my parent class, and then I do this. So the only thing that has to change now, in the old world, I would have done this, equals quote unquote hello. Now I just have to have a slight layer of indirection whereby I instead call this macro ns localized string, or this method function, which then takes two arguments. One is the name of a key value that I want to do a lookup on, and the second is actually a comment. So the comment is useful for making it easy for you can generate these localization files, as we're about to see, so that if you want to hand it to a French-speaking friend or a Chinese-speaking friend, you can actually have automatically generated for you a whole bunch of key value pairs where the values are blank, but they're all commented, so that you can express to your friend, this should be a local greeting, quote unquote, to say hello to the user, some language that English-speaking translator would understand. So I then did this in advance. I went up to File, New, File, and then under Resource, I chose Strings File. And then I deliberately named the name of the file localizable.strings to adhere to convention. And then I got one of these files, localizable strings, which looked like this. And I filled it with some generic comments. But then I chose my own generic key, and I gave it my own choice of values. Notice that these are essentially preprocessor type directives whereby it's not NS strings. So no @ here. Left is the key, right is the value. And there's no comment in the file because I did it manually. So what I then did, after making this very simple file, and there was no hierarchy yet, there was just one copy of localizable strings because I went to File, New only once. I then opened up the inspectors, I clicked on the file inspector, and then I went to the plus and I chose Spanish from the list. And voila, it ends up here, because I already did this in advance. That then gave me a little hierarchy here. And in Spanish, I went in and I keep the key the same. You don't translate the key, you just translate the value. So the end result here is that if I'm in English mode, I'm going to see hello world. But if I'm in Spanish mode in the device or the simulator, I'll see hola mundo instead, which I do here again by default. Yeah?
Is there a limited selection of languages built into iOS? Or if I had an exotic language that I wanted to support for some reason, would that be something to build?
Good question. The languages that are supported by iOS are standardized because users cannot extend. You can't just download a language pack for the iPhone. So what you get is what's available under the settings menu. And all of those languages have keys like EN for English, ES for Spanish. So you're limited to what the iPhone itself supports. And they would all appear then under the drop-down or under other there. Good question. Sorry?
No Klingon.
No Klingon, no pirate or any fun ones as well. And as an aside, only because I tripped over this myself, this example previously was going to be ciao mondo, which is in Italian. But there appears to be, as best I could tell, a slight bug, and some Googling confirmed, with Italian now, whereby, well, at the time, And maybe it was fixed in 4.3.2, which just came out quite recently. I think in 4.3.1 of Xcode, there were two different Italian localizations. One was like Italy mainland and Italy somewhere else, maybe Switzerland. And the phone itself, the simulator, did not know about the encoding. It was IT-something and IT-something else, which is why I rewrote the whole thing to be in Spanish. So I mention this only in case you run into an issue where your language of choice isn't working. Do Google to make sure that Apple hasn't made some recent mistake. Yeah? Why is it not in the plist format? Good question. I don't know the history there. I will say that it's actually a good question. Part of it might be convenience, I'm hypothesizing, because with the plist you actually need your translator to understand XML, frankly, or the translator needs to have Xcode, so you get a nice little GUI for it, whereas in this case it's just a text file. They can use Notepad. That might be part of the motivation, but beyond that I can only guess. Other questions? All right, so we've got two other big fun topics tonight. One's going to be unit testing and actually writing application and logic level tests to make sure your code is correct with higher probability, and also some two-dimensional graphics, including a resurrection of the classic game Pong. So why don't we go ahead and take our 5-minute break here, and we'll return then with those topics. All right, so we are back. And all this time, when we've been starting off new Xcode projects with the template, there's been a box that says include unit tests. And whether or not you've checked that would influence whether or not you actually get some unit test code out of the box that looks a little something like this. So let me go ahead and create a new single view application. Let me go ahead and call this demo. And then let me actually check this time, not just use automatic reference counting, but include unit tests. Let me then click next. Let me go ahead and just save this wherever, as on my desktop. And notice now you get the same skeleton code we've been getting in addition to a folder or a group called app name tests, capitalized as such, demo tests in this case, that has demo tests H and demo tests M inside of it, and then some plist files down there. So what do we actually get in here? Let's take a quick look at the header file. So not all that revealing, but there is a reference to this SendTest framework. So this is the framework that Apple adopted a while back that allows you to implement unit tests in a manner consistent with like CUnit, JUnit, PHP unit, if familiar with those fairly common frameworks. And if we go into my M file here, notice that we get some skeleton code for some unit tests. So for those unfamiliar, the way unit tests work in this framework is that what we have right here are some so-called application tests. These tests are really designed out of the box to test your UI, any outlets you have, actions and the like. And this is to say that the template is wired and configured in such a way that when we run these tests, the simulator will actually run. It might quit pretty quickly because the tests can be run quicker than a human can typically interact with the simulator, but they will actually unserialize the nib files, create all of the objects and such, and so forth. By contrast, you can also with Xcode create what Apple calls logic tests, which are similar in spirit to unit tests, but they don't require the full-fledged simulator. They don't require the UI. Logic tests are typically meant in iOS to test your models. So if you have a model for storing data, model for storing your gameplay logic or the like, you can test just that object by instantiating it largely in a vacuum and then passing messages to it. So out of the box we get this, and I mentioned that out of the box you get application tests because if you manually add application tests later, it's a little annoying. You have to follow the steps at the URL I'll put up again in a bit, but you have to tinker with the plist and actually paste some settings. It's a little annoying. So best to think about unit tests in advance, so at least Xcode wires some things up for you. So here I have these framework files, and then I have these three stubs here. I've got setup, teardown, and test example. And the heuristic that the SendTest framework uses is as follows. Any method whose name starts with TEST in this .m file is going to get executed as a unit test. And before the framework executes any such method, for instance, test example, it will first call setup, then it will call the unit test function, then it will call teardown, then it will call setup, then it will call the next test method, then it will call teardown, and so forth. So in this way, you can ensure that each of your individual tests starts with a known state of the world, where you can allocate memory, you can deallocate things, you can do whatever kind of setup you want so that every method is effectively executed in a vacuum, so that one does not affect the other. So what kinds of things might we want to test in, say, how about our ATM example from a while back? Recall that we had this example here that if I ran would create a UI that looks like this, a bit like a calculator. iPhone simulator, let me choose this, ATM. So it looks a little something like this. So recall there were a couple pieces of this puzzle. There was the UI, which was embodied in the nib. Those buttons were wired to various actions. And what were the actions that we defined? There were 3 of them, if anyone recalls. Yeah?
Input numbers and build that amount, and then clear that, and then add it to the balance.
OK, good. So we had, and I'll summarize as we had an action for deposit. And in fact, the method was called deposit. We had another one for clear, which clears the balance. And then there was one multi-purpose one called digit, which handled all 10 of the numbers. So 3 IB actions, and any of those buttons could send the related message to the view controller object. Now, meanwhile, we did have a model. This was the first example we introduced where we had a model and not just a V and a C in MVC. And what was the model class in question? It was the account. And this was a really trivial model. It was just meant to represent a bank account. But a bank account a couple weeks ago only stored what information? A balance for one user, no less. So super simple, but it did allow us to sort of abstract away the detail of a bank account into its own class that we needed to instantiate and pass messages to if we wanted to update its balance property, either by incrementing or decrementing. So there's a couple of things we can test here. One, I'd kind of like to test that the bank account itself works correctly. For instance, when I make a deposit, is that deposit reflected in the account balance? When I make a withdrawal, is that reflected in the account balance? Now, in reality, that's really only going to end up testing my getter and or setter, which is a little presumptuous because hopefully the @synthesize keyword generates correct code, but it's still an opportunity to test. But there's also initialization that I should probably test. The one method that we did implement for the account model, recall, was an init method that probably did what? What initialization is necessary for an account? The amount, by default, should be 0. So super simple. So it sounds like a super simple test. And indeed, unit tests by design are meant to be as small as possible and to test as little as possible at once so that it's super clear what, in fact, is broken in your code when one of these tests fail. It's a lot harder to chase things down if you're testing, say, a dozen things at a time. Best that these things be refined. So what might we want to test then, not in the model, but in, say, the UI? What could go wrong in my implementation of this ATM? I touch the number 2. What could go wrong? What's that? It deposits immediately, or it says 5, right? So those are possible mistakes I might make. Now, how do I test that? Well, in terms of the UI, when I press 2, what do I hope will happen? It'll appear in the label, right? Now, I don't know what's happening in the models. That could be a whole separate testing framework. But when I describe application tests, that is UI tests, when I press 5, or when I press 2 rather, I want to see $2 in the upper right hand corner. So how am I going to test this? Well, it's actually easy to test things in one way. I can very easily pretend to push the number 2 by just sending the digit message to my view controller class. So we'll see how we can do that. I can very easily talk to the UI text, the UI label via an outlet. So thanks to actions and outlets, we already have a way of talking to the UI, and my unit tests are going to be written in code so I can piggyback off on those same preprocessor tricks of IB actions and outlets to actually have that communication. So let's take a look. Let me simulate part of this, and then I'll open up the pre-baked version of this. When we first had the ATM class, I had no unit tests, so let's pretend that this folder and this folder do not exist as of 2 weeks ago, which they didn't. So suppose after the fact I realized, damn, I really should have implemented unit tests a while ago, so I have to manually add them back to the project. Well, one of the simplest ways to do this is not to just go to File, New, and create a unit test file, but rather a new target. And if you choose a target, those of you familiar with ant and build files or make and make files, it's configuring a new sequence of steps to run code, run commands. And a target in this case doesn't need to just run your code. It can in fact run your tests instead of your actual code. So the template I want to choose for my new target under this model is under iOS, Other, and then the Cocoa Touch unit testing bundle. So that's the one choice I want to make here. I'm going to go ahead and hit Next. For product name, the convention in Apple is to choose the name of the test, the name of the application itself, and then if these are going to be UI tests, to call it application tests, and spaced with no spaces, capitalized as such. So just a convention, and I'm going to leave the company identifier the same. I'm going to use automatic reference counting. I'm going to keep this in the same project, and I'm going to click Finish. But then I'm going to fake this because I already have this target. As soon as I do click Finish, what I'm going to see is a new target appears up here. So 2 weeks ago, the only thing you had above the break here was ATM. But now that I just created ATM application tests, a new target appears up here. And as we see, it's already targeting the simulator, which is good. And we'll also see, if I go back and click on the ATM project itself, notice that under targets 2 weeks ago, we only had ATM. Now I have ATM and ATM application tests. Meanwhile, if I go through those same steps again, new target, and just arbitrarily call it new ATM logic tests, I would get my third target. And the nice thing about this is that it then wires everything up in a useful way, even if I didn't have the foresight of clicking that checkbox the first time around. Okay, is there a question? All right, so how can I go about testing this? Well, let me go into my prefabbed version, and let's go ahead and look at, let's say, just the logic tests, because these will be relatively easy. So here is my header file, and it's just saying, give me a class called ATM logic tests, and it's going to descend from this framework class. All right, so in my M file, thankfully, there's not all that much to test because I kept my model so simple, but there's a few things. So let's look at the top first. This is a design decision. It doesn't have to be here. But I decided to give myself, in my ATM logic test class, a private property called account. So if I want to test this model, I'm going to have to allocate an instance of the model. So I just need a pointer there too. And if I want to allocate this object in my setup method, but then test it in a test method, it has to be some kind of global pointer. And the easiest way to do that is like an ivar, or more sophisticatedly, a property. So that's why I have this property with my testing class. So I can create it in one method, but test it in another, and then tear it down in a third. So that's familiar in spirit. And in this case, it is strong because I'm going to do the allocating. This is not coming from the nib. In fact, there's no UI involved in this test. It's just testing my logic in my models. I synthesize the account. Here's going to be my setup method. Notice that the U is in fact uppercase per the SendTest framework. I call my parent class, and this is just a little note to myself. I wanted to see that I was calling setup while debugging. I want to go ahead and allocate an account, and then I want to call one of several possible assert methods. So it's the SendTest framework. So all these methods start with all these functions start with st. St assert not nil does what it says. It's going to take an argument that had better be not nil. Otherwise, this assertion is going to fail. So generally in programming, whether it's C or Objective-C or other languages, an assertion is something that must pass in order for your code to proceed to the next line. If that assertion fails, then the code terminates there. It's not going to kill the whole program, but that unit test will fail. And then the next one will begin after a teardown and a setup. So this first argument is the thing that in this case had better not be nil. And this should make sense, right? If self.account is nil, my init method is broken. I didn't actually initialize it. The second line here is for what probably? Yeah, it's just diagnosis. This is for me, the developer. It's a comment. Once I've written hundreds or thousands of lines of code, I don't want to have to look at the line and figure out what I was testing. I want the error message that the framework generates to just tell me what was wrong, because I knew at the moment I wrote this test. So we could test this in a couple of ways. We could test the actual account balance here, but thus far, in my setup method, the only thing that had better succeed in the setup of this is allocating the method here itself. I could arguably put this into another method altogether, but in this way, I'm able to then have it a global pointer of sorts for all of my test methods. Here's the method that I'm going to use to test the balance. I called it somewhat reasonably test balance. The only important part of the name is that it start with TEST in lowercase. I write a note to myself that balance should be $0 initially. How do I test this? In this case, I chose st assert true, and you can infer now there's st assert nil, st assert false, and a whole bunch of others, and autocomplete should answer, should give you a list of the options. Self.account.balance equals 0. So that's a Boolean expression. It had better evaluate to yes or true equivalently. And if it doesn't, I'm going to see balance is not $0. That's the comment. So I could test a couple of other things. Like I could test the getter. I could test the setter, but frankly, if you're going to start testing all of your synthesized getters and setters, it's probably not the best use of time in code. It's probably reasonable to assume that those things that are automatically generated are correct and that your focus should be on anything you write. You should distrust yourself more than any synthesized code. As for teardown, is there anything I should do here? Scroll down here, a little message to myself, but that's really all I need to do. Back in the day, a year ago, I would have had to have a release call here to free up the memory I had allocated in my setup, but no longer. Any questions? Yeah?
So teardown will just release everything. It assumes that the app has ended its cycle.
Correct. And in this case, it doesn't need to do anything, but it's your opportunity to clean some things up. All right, yeah.
Is it possible to have tests dependent upon the results of other tests? I would imagine that an object of any reasonable complexity is going to require some kind of a decision tree to test its state at various points, or is it just literally each method is its own vacuumed universe to test?
So the test methods themselves are meant to be executed in a vacuum with no dependencies on previous methods. If you want some stuff to have happened, it needs to go in the setup method, or you need multiple lines of your own code in your own method. Or a very common approach too, though, is you don't want to, in principle, test too many things at once. So there's this notion in unit testing of mock objects, whereby you yourself might manually construct an object, an account object in this case, that's constructed exactly the way you want it to be, or respond in exactly the way you want it to, as by overriding its methods and testing a subclass, and then only test the one piece of code you care about in that particular method. So you avoid the dependencies by manually constructing an object that conforms to your expectations. All right, so let's see this in action. It's actually pretty easy to run. Whereas in the past, we've always been choosing this run button to just run. We can now do this. I'm going to change my target to be ATM logic tests. It actually doesn't really matter what simulator I use here. But I don't want to click run now. I actually want to click test, because test will now ensure that my test methods are executed. And that's good. Nothing happened. It's a really good situation. So bad would be this. Let me accidentally do something like this. Let me go into my account.m file, and let me all of a sudden give the person $100, which is not correct. This is a bug. An adversary has now made my code bad. So now let's go to my ATM tests. Notice that this test had better not pass anymore, because it's not in fact 0. So let's go up to test and run again. Build succeeded. Uh-oh, good. So now Xcode's not even going to let my code proceed. It's highlighting in red, and it's giving me my own user-friendly message that I wrote over there to the right, and it's pointing out which of the tests failed. And so now it's up to me to diagnose this. One of the upsides now of targets, as an aside, is that I can, for my application itself, make it a dependency of another target like this, so that if you want to ensure that you can't even build your code and you can't even deploy to a device or the simulator until you pass all of the unit tests, you can, by way of the project properties, make an application's build dependency by way of, here we go, target dependencies. You can start playing around with these menu options and make sure that one target has to pass in order for the other to actually be built. But how about now UI? So now let me pretend like I went to File, I went to New and Target, created one called ATM Application Tests, and that gave me this group, which we'll look at in a second. Yeah?
So you tested there was one test method,
Mm-hmm.
right? Setup and then tear down just once, or you
just once. Well, so you write one setup method, you write one teardown method, and then you write as many test foo, test bar, test baz methods as you want, and they will be executed as triples. Setup, test foo, teardown. Setup, test bar, teardown. Setup, test baz, teardown. So each one will get a known state of the world.
But you need setup and tear down for every method?
No, just one. In fact, you won't be able to implement the same method twice.
Right.
They'll get called multiple times, but you write it once.
Okay.
So setup is your opportunity to allocate stuff you need. What's that? Good question. I don't know. I suspect they might be executed in the order in which they're defined, but I don't think it's defined per se, so you should not assume anything. I would typically write them alphabetically or in the order that I care to think about them, but you should make no assumptions. And you shouldn't need to, because again, they're executed as these triples. Yeah?
So I think I already see the answer to my question there. So do the application tests, do they then, or or any of the tests, do they then have access to resources that would be copied into the bundle? So say you had a common data set that's required for the application, so you know, like a SQLite database, would the tests have the same access
Yes.
to that database as anything else? You can just treat it like treat content like any other data, like you would
Correct.
for the rest of the environment, Coco?
Correct, yeah. So just for the camera, if you do have some supporting files like a SQLite file or plist file, yes, absolutely. Because you're just writing additional Objective-C classes, those two can talk to those same files in the bundle. So you can use the same files for your testing. Or even include simpler ones, smaller ones, if you want to know the state of the database in advance. All right, so application tests. These are going to be a little longer, but a little easier, I think, to wrap one's mind around because you're just manually executing things that the UI would otherwise do itself. So here is ATM application tests.m. So same starting point as before. This time I declared a few properties because in this test I really wanted to test my whole application. And we've been telling the story ad nauseum now for weeks about you have main, you then have UI application main, and then you have the app delegate, then you have the view controller. Some of those classes I'm actually writing, or at least touching myself. I'm not doing main.m or writing any code there, but I am writing some code in app delegate potentially. I am writing code in view controller, and I might be editing the nib or creating a view myself. So the three things of particular interest, at least for a simple application, are those three classes. Is my app delegate correct? Is my view controller correct? And is my actual view correct? So here in advance, I just want 3 pointers to the objects that will be created for me. I'm not going to manually allocate an app delegate or a view controller or a UI view. This time I'm going to rely on the simulator and really iOS in running my application. But I need some pointers so that I can patch into those objects and ask them effectively, are you correct? All right, so here are my 3 properties. Let me scroll down where we synthesize each of them in our typical way. And now down here, my setup has to do a little more. This time my setup method is actually going to figure out what these pointer values are. So self.appDelegate needs to be a pointer to the app delegate. How do I access that? It's pretty easy. I call UI application shared application. That just gives me, it's sort of a singleton instance. It gives me a pointer to the app delegate by calling the delegate method here. So that gives me that pointer. How do I get the view controller? Even easier. Self.appDelegate.viewController. How do I get the view? Even easier. Self.viewController.view. So now I have 3 pointers. Now, frankly, I could probably get away with 1 pointer and then just traverse them in exactly the same hierarchical fashion. But I just want to think about these things as 3 distinct objects. So I gave myself 3 properties for convenience. Now, how do I test the app delegate? You know, I didn't write much in this app delegate. To be clear, let me go to appdelegate.h. There was no magic here. It's pretty much empty. There was not much magic here. In fact, that's prefab code. All I did was delete all of the other stubs that were just green comments. So really, testing my app delegate, I'm going to assume that this is correct. Could Apple literally wrote all of these lines? Though if I were paranoid, I could write some testing code there too. But really what I care about is that when my program starts, my app delegate had better not be nil. Because if it is, things aren't going to work. Now, frankly, it's probably not going to be nil anyway, and you'd be the first to notice if you have no application. But if you really want to be rigorous and make sure you didn't screw up the instantiation of that object in any way, it's not unreasonable to just assert that self.appDelegate had better not be nil. So that's one test there. Arbitrarily named. It could be called test foo, but it must be called test something. How about the clear method now? So when I write unit tests, I kind of try to tell a story to myself so that I know from the comments exactly what the behavior I'm expecting is. So in my test clear, this method is meant to imply that I'm testing the clear button. So how do I go about calling clear? Well, I can do this. I don't have to simulate a finger touch per se. I can assume that the touching of the button will be correct in this case. But self.viewController can be manually passed the digit method. But digit was an IB action. What arguments do IB actions typically take?
The actual UI view that's called.
Yeah, so a pointer, generically called the sender, which is a pointer to the UI view that invoked this action. So digit takes some kind of pointer, an ID, generally speaking. So how do I actually get at the number 1 if I want to simulate touching the number 1? Well, there's this nice little method that allows me to access UI view objects from the main view via their tag. And recall that I manually tagged the number 1, 2, 3, all the way through 0 using the tag field. So I can just say to the view, give me this child view that has tag 1. And that gives me a pointer now to the button labeled 1 without having to worry about a human finger triggering it. So now I want to assert the following. Assert that it's true that self.viewController's deposit label, its text value, is equal to the string quote unquote $1. So deposit label is what? The actual label, and it's one of our IB outlets, and that gets wired up for us because of the blue lines we dragged and dropped 2 weeks ago. This gives me the actual NS string. This is the pointer to the object. This is a pointer to the string that's stored in the object. And I can't just use equals because I'd be comparing pointers. This does a string comparison with $1. And then here's my comment to myself that deposit should be $1. So that's a pretty straightforward test. How about now pressing clear, which is the whole point? And I'll come back to why I did this and how we could do this in a moment. So clearing should yield $0. So same idea. Self.viewController, let's pass the message clear. And frankly, this time, remember I didn't even bother giving the clear button a tag. I'm just going to pass a nil as the sender because for testing purposes, it doesn't matter that the clear method does not need a pointer to the button, as you may recall. We only needed that for the digit method to determine which digit was passed. But according to the little blue lines that I dragged and dropped, there's only one UI mechanism that's going to pass clear, and I don't even use the pointer that's passed in. So to keep things simple, I just did nil rather than go give it a tag or something like that. So now I want to assert that it's true that the deposit label's text value is equal to $0. Now I'm kind of cheating here. This isn't really practicing what I preached a moment ago. Where am I kind of abusing the notion of a unit test here? Yeah, I'm kind of cheating, right? It's like I like the idea of pressing a digit and checking that it's 1 and then testing clear and making sure that it is now 0. But really, if I'm testing clear, this is the code I should be testing. But right now, this unit test clear, is going to fail if what other method's broken. So if the digit method's broken. So really, I want to sort of mock out this object that I'm checking. It seems to be the deposit label here that I care about. Frankly, there's nothing stopping me up here, instead of calling digit at all, there's nothing really stopping me from changing this label to actually be $1, and then ensuring that when I hit clear, it then changes back to 0. And so long as the IB outlet works and the setter, therefore, that was synthesized works, that's one way of eliminating this dependency. If I'm really not comfortable with that, it's still a pretty short method, and I could just call this test digit and clear, and that's kind of a reasonable solution too. But it's really the thought process that I emphasize is the takeaway here. Test clear is indeed related to what I'm doing here. But I was starting to push it a little bit here because it's not going to be clear if one of these tests fails at first glance. Is it digit or is it clear? And if I am working with someone else and he or she is responsible for digit, I'm responsible for clear, it's hard to distinguish exactly where the fault is or who needs to go intervene with that problem. So at least keep that in mind if implementing unit tests for the first time. We don't require it for Evil Hangman, but will for the student choice specification. All right, how about another one here? Test deposit. Let me just roll that back to before. Test deposit. I'm being a bit truer here. So at top, balance should be 0 at first. So I check that the balance label, not deposit label, is equal to $0. Then I deposit $1. So I press the digit button a couple times. So let's say I press 1. And then what else do I? And then I call, where is it? Digit. Assert that's true, that it's actually equal to $1 now. Now I call deposit. So there I again kind of blurred the line. I'm not just testing deposit now, I'm also testing digit again. So at this point my digit method had really better be correct. But there too, I could perhaps factor that out. But here too is the more interesting takeaway for this method is that testing the deposit of $1 is fine. But deposits had better work for another scenario, not just pressing one button, but making sure that 1, 2 is actually working as well. So in general, when thinking about unit tests, try to break them up into your mind into cases. So an interesting case, or corner case really, would be the $1 deposit. Maybe the $2 deposit, so it's at least multiple digits. Maybe you screwed up 3-digit deposits, but likely if you got 1 digit and 2 digits, 3 by induction is going to work, even though that's a bit hand-wavy. But you should maybe try $0. If there were a minus sign, checking -1, and really thinking about in your unit tests, those kinds of cases to test. Yeah?
With this and the previous example, you said that if your deposit doesn't work, then obviously your whole test fails.
Mm-hmm.
But if deposit doesn't work, doesn't it stop, and then wouldn't you see the, at deposit should be 1, and you know that it failed on deposit, or on the balance should be 1, it failed on that part of the test, not further down?
Indeed. So it would fail on the first test, and so that would actually be a revealing tell about where the error is. So it's really then the spirit here in part where to test as little as possible so that you can isolate errors yourself to the code, the specific code you're actually trying to test without worrying about any dependencies. Yeah?
So we could have accessed the account object as well, right?
You could. Yep, you could, absolutely.
Just thinking those cases where the action is not revealed in the UI.
Correct. So absolutely. If you also wanted to dive in a little deeper, you could mutate the model itself, which we don't need the UI for, but the UI does, of course, need that for it to work. All right. So many ways to do these. And test digit is actually, so this one, should have showed this one first. I was so rigorous with the testing of the digit method here that I tested these sort of corner cases. Testing a 0, then another corner case occurred to me. What if you hit 0, 0? That had better still say just 0. Then I thought about $1 case, then the $12 case, and then I felt that exhausted really the possible scenarios. So it's not perfect testing, but here too, if unfamiliar, you might have heard the expression regression test before. The whole idea too behind unit testing is that if you still screw up somehow, when you just fail to capture some case and then someone reports to you or you notice there's a bug in your code, the notion of a regression test is generally to go into your own unit test with version 2, write a new test that would have caught that mistake you made the first time around to ensure that over the next several months of development, you never again regress to make that same mistake again, because that new test will now tell you proactively that you have erred with that same bug. All right. So, and teardown in this case doesn't have to do anything. I left the stub here, but this technically doesn't need to be here. And just as an aside, I also left in place the default one that we saw briefly earlier, test example. So if you're playing around with unit tests on your own without writing any code, realize out of the box they will fail, because the test example code that Apple gives you in the template literally calls stfail, which fails no matter what. So don't worry if your code doesn't seem to work just because you've introduced unit tests all of a sudden. All right, so lastly today, we thought we'd introduce some actual graphics. Not the most Angry Birds of graphics, but at least something that gets us a little closer to interactive games that don't rely on the built-in UI view mechanisms entirely. So let me go ahead and run this before we look at how this is actually working. Core Graphics is a C-based library, as are a lot of the lowest level libraries. And I thought it would be fun in landscape mode here to just implement a paddle, which I imagine could be the beginning of a Pong-like game. And I'm holding down my mouse button now, much like I'd be holding down my finger. And I just wanted to implement a program that has a little goalie of sorts that can go up and down. It doesn't matter if I move left and right, but it does follow the y-axis of my mouse's movement. So how can we go about implementing this? Well, main.m has nothing of interest as usual. AppDelegate.h has nothing of interest beyond the template code. AppDelegate.m similarly is not doing much at all. So let's take a look at ViewController.h. Okay, similarly skeletal. And then the M file now gets interesting. So the first thing I did was have a private property, just because I've gotten to this habit of using class extensions and keeping it in my M files. But notice that it is a paddle view. And see, even I fell into old habits. This should be not retained, but strong, even though they have the same effect here. So it's going to be read-write by default. So paddle view, I don't know what that is yet, but as you can see up top, it's apparently a class I wrote. So all this time we've been using UI buttons, UI labels, UI text views. These are all descendants of UI view that other people wrote. Finally, I'm going to implement my own view. And the motivation is I want a little paddle widget that does not come with Xcode by default. So this is going to be a pointer to that. It's not an IB outlet because I'm going to create it in code, not in interface builder. I'm going to synthesize it down here, and here's my initialization method. It looks pretty similar as usual with the initialization with init with nib name and bundle. But here's how I'm going to allocate this. I'm going to allocate a paddle view. I'm going to initialize it with a frame, whatever that is, and then there's CG rect make, and then 10.0f, 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 60.0f. So what is this referring to? Well, 10, 10 is referring to 10 points over and 10 points down from the top left-hand corner of the screen. The other 10.0f is 10 points wide and 60 points tall, and that's pretty consistent with what we saw on the screen. It was a little offset and down, and it was fairly tall and rectangular. So those are the coordinates for a rectangle that I want to make. Indeed, cgRectMake is a function for core graphics make rectangle that creates a rectangular object of those given dimensions. So I said points a moment ago and not pixels. This is because Apple's decisions as to resolution has been changing. Now the iPad, you recall, is resolutionary. But the upside of the iPad 3's new resolution is that it's no longer 1024 by 768. It's literally double that, 2048 by whatever, which is good because it's a constant multiple of the original. And so this is exactly what happened when the Retina display came out for the iPhone 4, whereby you have still the same coordinate system. Indeed, this is like an iPhone 3, the chassis for it. This top coordinate is still 0, 0, and we think of x as the horizontal axis and y as the vertical. But Apple still allows you to model the screen in terms of points. And a point could be 1 pixel, or it could be 4 pixels. So you get 4 pixels by doubling the x-axis and the y-axis from 1 point. So the idea here is that you can still model the screen as 320 by 480 for the iPod or the iPhone, and the iPad has these same dimensions. But even if the user has a fancy new Retina display, everything will just scale up nicely for you, at least if you're using some built-in UI view objects. Now, if you're actually using graphics and made in Photoshop or the like, then you might actually care to have truly a new graphic that's 2048 pixels wide, so it doesn't just get zoomed in on. But at least for vector-style graphics, like buttons that can be drawn mathematically, as opposed to with bitmaps with a prefabbed graphics program, you can scale up very nicely. So there was actually just an article or more Mac rumors today about the next iPhone. Maybe it's going to be a 4-inch screen. And there's actually some non-trivial mathematical implications for the resolutions of the displays, whereas the Android market's kind of a mess in terms of the various resolutions you can have in devices. I mean, Apple, one of the upsides of their control is that it's just a lot nicer for developers to know that you can always assume a rectangle of a specified size, or at least proportions. So in that sense, it's a good thing. So how do I go about creating this paddle view? First line, we discussed, I allocate it. Second line just has to add, as a child of self.view, this new view. So recall from Interface Builder, we've always had that little drop down where you see view, and then in a hierarchy of all of the objects I've dragged and dropped, this is the code analog. I'm saying to the parent object, self.view, add a subview. Drag and drop this paddle on top of yourself, self.paddle view. So that's all I'm doing in the initialization. And now I've got my should auto rotate to interface orientation. Notice I did change it. I only wanted to arbitrarily support the rightmost orientation. Notice over here too, I only checked this one. And this supported device orientation has to do with the device's behavior when you first start up. It will, and when it actually reorients itself. But for now, let's go back to, the viewcontroller.m. And now we have this. The only method I needed to implement is something called touchesMoved. So the nice thing here is that this is going to be a method in the view controller that's called anytime the user touches the screen, wherever it is. And what I'm going to get back is apparently a pointer to an object called NSSet. And an NSSet is just, it has nothing to do with touching per se. It's just a collection class, like an array, but there's no duplicates in a set. And then I also get a pointer to the actual event that was triggered. So how do I go about accessing the user's finger touch? Well, I could get back the x, y coordinates, but I don't really care about the x. I only care about the y because I want the paddle to follow the user's finger. So I'm going to ask the question as such. I'm going to ask the event for all of the touches, and then I'm going to say, give me any object. Because really, I don't care what finger it is. I just want any of the touches that the user has pressed here. I'm just going to follow one of the fingers in this case. Now I need to actually convert this touch object to a point, an xy coordinate. So I ask the touch for its location in the view, and I pass in the view itself. So it knows how to orient itself within the rectangle. And this is the entire screen, but it is in fact the rectangle in question. Now I'm going to update the paddle view's center property. So we haven't talked about this before, but all of these UI view objects all this time, buttons and text fields, have always had a center property. And all I have to do is update it to be wherever I want to reorient this little paddle center. So what I'm going to do is I'm going to make a new point, core graphics point make. The x-axis is going to remain unchanged. I'm going to just get self.paddleView's center's current x-coordinate, but the y-coordinate is going to match the finger's location. And this is going to get fired every time the user touches the screen and moves his or her finger up and down. So the result is it's going to always follow the user's the y-axis of the user's finger. And notice here too, user interaction enabled. This means it's going to the view is actually going to respond to these key presses. So the end result again, if I build this and run it, is I now have the ability to move up and down. So not all that interesting in and of itself, but let's take a look now at the paddle view. How is this implemented? So paddleview.h doesn't do all that much. It's just descending from this same old UI view class that all those other widgets have been. But the M file does a little bit of math. Not much. Actually, no math. Just mentions some numbers. Even better. So I'm making a rectangle this time, but it's going to be a why did I call it a square? Shouldn't be called a square. Doesn't need to be called a square. Should have been called a rectangle. I think at one point in time I made a square out of it. So cgrect is going to be a struct that's called square, accidentally here. cgrectMake is going to return to me a struct that is 0 pixels in, 0 pixels in, 10 pixels wide, 60 pixels tall. So this is no longer offset. So notice the difference here. Here I'm sort of creating a graphic that is 10 pixels wide by, maybe this is why, I can only make a square with 4 equal fingers. So we have a rectangle that's 10 pixels wide by 60 pixels tall. I want it to fill this entire rectangle. This is my canvas. Now in the application, I'm going to position this 10 by 60 thing over 10 and down 10 points. So that has to do with just an offset. But the graphic itself is going to be 10, 60, hence the zeros here. Now I have in this, you can think of this as a very old school painting program. I can pass the UI color class the convenience method white color, which is going to set my marker or my paintbrush to white, and then I'm going to call set, which is going to set the current rectangle to that color, and then I'm going to call UI rect fill on passing in that square. So in short, this draw rect method, which I didn't mention by name until just now, is a method inside of every UI view class that gets called when the program needs to know how should I draw you on the screen. And everything's modeled as a rectangle, so this is specifying how this object should be drawn on the screen. Buttons are drawn with some rounded rect borders. Text fields are drawn sort of more rectangular, but this is the function for core graphics that's called when asked, how should I present you visually on the screen? But the logic is now back in the M file, whereby I allocated this thing and then moved it around in my viewcontroller.m after adding it. So now let's use this as just a building block to a much more interesting application. Well, interesting as of 20 years ago. So this is Pong. And before we spoil the result, let's take a look. This time I decided, just for kicks really, I was going to implement the paddle with a graphic. We can do it this way. This way I can make it much sexier than just a white rectangle. However, all I made with Photoshop was a white rectangle. So paddle.ping I dragged into supporting files. Ball.ping is going to be even more underwhelming. It is just a smaller white dot that I drew with Photoshop. So, but the point is we could generalize this to be a more interesting graphic. What's that? There's my square, actually. There's my square. So my viewcontroller.nib got a little more interesting as follows. So one, I went ahead, and let me expand my objects at top left. I went ahead and dragged these objects in to the nib. So I'm not going to manually allocate a paddle, manually allocate a ball. I'm going to let the nib do that, right? This is one of the things it's good at, is just expediting some of these basic processes. So I dragged and dropped from over here to do that. Now my paddle, actually in my paddle view, there is no more paddle view class. Notice there's Pong view, which is different. There's no paddle view because I just used UI image view. And then I set the image to be ball.ping or paddle.ping. So I didn't need a custom class. I line these up, but I can also reline them up in code. And those two things up top are just UI labels. I chose the monospaced font so that the spacing would be consistent, but these are just UI labels as before. So meanwhile, my app delegate, uninteresting in both its H file and my methods file. However, I did do this. I realized that, the most infuriating thing for me with games is if you sort of background them and then they end up in some weird unknown state. So I decided after some tinkering that when this application is about to resign active status, that is, it's about to be backgrounded, I'm going to very quickly intervene and change the state of the world to be the kickoff position again. In other words, as soon as the app gets backgrounded, the ball is going to get put back in the center of the field and gameplay is going to be paused. Just because when the user comes back, I don't want the ball to quickly go into the goal or something like that. So I just arbitrarily decided to do this, and it's one of the first times I've used, at least in an example, one of these backgrounding methods. So now let's look in my view controller. There's nothing of interest really here except for this kickoff method, and I did mention it here so that it was being advertised to my app delegate class, who is the guy that imports me in the first place. So this is at least consistent with someone else having to care about that method. And now in my view controller class, let's take a quick peek at some of the details in here. One, I chose a default constant up top for the velocity, because the ball's got to move at some number of points per second or whatnot. So I chose 10 after some tinkering. Notice here that I have a private ivar called velocity, or underscore velocity. And I think I gave this warning last week. Whenever dealing with C structs, beware using properties because of the dot notation implications and getters and things being passed by value. So in short, rather than revisit that discussion today, for now, it's generally a better thing to make C structs be ivars rather than properties, because there are some unintended side effects. Now, I had a whole bunch of private properties, but most of them are fairly self-explanatory. I've got a whole bunch of outlets to the ball, to the paddle, to the labels on the left, the label on the right, the paddle on the left, the paddle on the right. So that's the first 5 of those. I have a Boolean for pause, because I realized after some tinkering, I wanted to be able to pause the game if it gets backgrounded or if someone scores. That effectively pauses the game, so I can put the ball back in the center. And then I have an actual integer for my score left and score right. So I could have had a model class that represents gameplay or something like that, but the only data I have to keep around is an integer for the left guy's score and the right guy's score, so I kept it super simple with 2 unsigned integers here. All right, down here now, I synthesize all of these properties, and then we get into the guts of the program. The method that's going to get called first, as usual, is this init with nibname bundle. So what do? I initialize the scores to 0, the models to 0. I initialize the ball's velocity. So it turns out I can represent the notion of ball velocity using essentially a vector, something with an x component and a y component. I can represent a vector with a point, because a point is just an x comma y, and that's all a vector is. If a little hazy on some of those mathematics, a point gives me x, y. That's all I need to represent the notion of velocity, speed. It's some speed going this way, some speed going this way, so the vector might be drawn like this. So it's an x comma y component, so I'm going to use a point, and it's going to go the same speed laterally as it's going to go vertically, but that's not strictly necessary. And then I'm going to schedule movement, so to speak. I'm going to use this NSTimer class, which I don't think we've used before. I'm going to have this timer fire every 0.05 seconds, and any time it fires, I'm going to pass the play message to whom? To myself, and I'm going to have this repeat. So this is like the JavaScript method setInterval, and I'm going to call the method play again and again and again really fast. And you can perhaps infer from that, that's how I'm going to create the illusion of continuous movement. Every 0.05 seconds, I'm going to move the ball probably 10 pixels or 10 points over and down or over and up. So the kickoff method is what's eventually called when I touch the screen. So let me, not all of the details here are necessary, but here's what I'm going to do first. Touches began. In order to kick off the game, I decided the most intuitive approach would be just touch the screen anywhere, and the ball gets kicked off. So I have this method, touches began, which is very similar in spirit to what we saw before, but the only thing I care about is unpausing the game. So I'm just checking. If the game is paused, make it not so anymore. And now that's going to change a Boolean global, or the property called paused. And my play method, let's go there, because that was the one I first saw named. In my play method, it's a little involved, but this seems pretty relevant. When play is called every 0.05 seconds, if the game is paused, it's going to return and not do anything. So this is how I'm implementing the notion of pausing the game. Now, as for actually implementing the movement of the ball, how am I going to do this? Well, first I need to update the ball's center to match wherever it is, its x location, plus the velocity's x component, comma, wherever it is y, plus the velocity's y component. So in other words, if the ball is here and the velocity is 10, 10, it's going to move it over and up, over and up, thereby creating a diagonal line. So there's going to be some interesting opportunities. If I'm bouncing off the walls, I'm going to have to do some billiards type reflections to have the ball bounce around. And here, let me wave my hands for time's sake and not focus too much on that, but it's pretty much going to end up being fairly basic arithmetic, whereby when it bounces off a wall, I'm going to invert one of the directions of movement. So if it's going this way, I really want it to keep going that way, but down, so it becomes essentially a 90-degree angle off of the wall. And there's not going to be any friction or spin or anything fancy like that in this game. So the arithmetic here is just handling literally what the comments say, bouncing off the top and bottom walls. How? I decided that if the ball center is fewer than 5 points away from the edge of the screen, recall that 0, 0 is the top, that means you're touching the wall. Similarly, if it's more than, well, down below, notice I'm checking the width of the screen. I didn't want to hard code in some number of points, just in case Apple changes things eventually. I wanted to get the width of the screen dynamically, rather than hard coding in 320 or something like that. So for now, let me just whiz through the play and say that this handles the bouncing of the ball just by updating the center in that way. And what else is down here too? Touch is moved, I stole from the previous example. Touch is moved just has to move the paddles up and down. Now I decided in this case that I'm going to move only the right paddle. That's going to be the human. The left paddle is going to be whom? Take a guess. It's going to be the computer. So right now I have artificial intelligence in this simple little game. And I zoomed over that, but let's actually zoom back up to the play method. We looked only at the ball moving around, but notice there's this chunk of code. Move the opponent as the ball approaches. So if the ball is negative, so if the ball is approaching the adversary, that line of code implies, go ahead and move the paddle up and down in lockstep with it by simply adjusting its Y component in a certain way at this particular speed, which I just hard-coded so that we only have one opponent whose velocity is not at all variable. Finally, Pong view, I decided that I wanted to do a little something different. Well, we'll come back to that in just a moment. So here it is, the game of Pong, all these years later. All right, so notice I oriented it in this way. I'm going to go ahead and click. Notice the midline. We didn't talk about that. That's a special little feature I drew manually. So now I'm going to move my paddle up and down. I'm on the right. He's on the left. And the one downside of this implementation is that the opponent is perfect. He will never actually lose.
You made evil Pong.
I did make evil Pong. So anyhow, if I actually let myself lose here, then he gets a point. The kickoff puts the ball back in the center. It pauses. I click again, and it can play, and he's going to keep winning and winning and winning in this case. But if I really wanted to, you could imagine having a flip side view. You could actually change the length of the paddle. You could change the speed of yours or of his, change the speed of the ball. There's actually some interesting optimizations here. Now, what about this dashed line? Remarkably, I did not make that in Photoshop. I wanted to at least put a little bit of effort into the graphics. So notice that Pong view is just a UI view. But notice in the M file, I wanted to take the opportunity to use this draw rect method, partly to show how you can use it, but also to hint at the complexity of doing even some two-dimensional graphics programmatically. So one, I need to access this thing known as the context, which is sort of like the canvas of sorts. And then draw dashed midfield line is going to work as follows. This is a static initialization of a C array that conceptually is going to give me one line of white, one line of black, one line of white, one line of black. So that's the 1, 1. Then I have to set this dash line in the context, so the canvas, so to speak, where it's going to start, what the array of dashes is going to look like, and 2 is how big the array is. I need to tell it that proactively. Then I'm going to set the stroke color, like the paintbrush color, to be white in this case. Then I'm going to set the width of that line to be 5 points wide. Then I'm going to set, I'm going to move the paintbrush to this specific location. So it's 0 at the top and then 240 pixels in, because the whole screen is 480 points across. And then I'm going to have it go all the way down. So this is very sort of logo style drawing on the screen, whereby I'm moving the cursor, putting the paintbrush down, and then drawing down on the screen. And the dashes are the result of this dash line method and this stroke method being done together. Clearly an opportunity for Photoshop, if ever there was one. But this is how some lower level graphics would be drawn. And if graphics even far more sophisticated than this are of interest, realize that the iPhone does support the embedded version of OpenGL for three-dimensional graphics, which itself, frankly, could be an entire course. But any questions on these two-dimensional graphics? All right, so one of the objectives really for today was to seed you with some potential for the student choice projects. Realize you can go certainly beyond this. You can do things with mapping, with address books, with dynamic generation of emails. Realize the tutorials online abound as well as some of the recommended books. So certainly do dive into anything that might be of interest along these lines. And keep in mind, at the end of the semester, you'll have this opportunity to show off your work and also eat cake with classmates and with us. So I'll stick around for questions, but otherwise we'll see you next week for Windows Mobile.